everyone, I am Dr. A. Soumya, Assistant Professor, Department of Electronics and Communication Engineering. Today we are going to see the subject Sensors and Actuators. Subject code is AU3008. Unit 5 is Automatic Temperature Control Actuators. Here we are going to see the topic Semi-Automatic Controller Design for Fixed and Variable Displacement Type Air Conditioning System. Designing a semi-automatic controller for fixed and variable displacement air conditioning system involves integrating control logic and hardware that optimize system performance while balancing users' input and automatic adjustment. Below is the outline approach of this design. System overview. Fixed displacement compressor operates at a constant capacity irrespective of load conditions. Cooling output is controlled primarily by cycling the compressor on and off. A variable displacement compressor adjusts its displacement to match cooling demand, improving efficiency, uses internal mechanisms to vary the stroke of the pistons. Semi-automatic controller features allow the users to set desired temperature and fan speed, manual override for compressor cycling or displacement level. Next, automatic adjustment, monitor cabin temperature and adjust the cooling intensity to maintain the desired set point, automatically regulates the compressor cycling or displacement based on the load. Third one, system components. A sensor, cabin temperature sensor, ambient temperature sensor, pressure transducers, and actuators here used is a solenoid for fixed compressor, variable displacement control valve for variable compressors, and controller hardwares are microcontroller or embedded systems with the ADC for sensing the input. And next, user interfaces used here. Rotary knobs or digital buttons for the temperature and fan speed control, display for temperature set point and status indicators. Fourth one is the control logic. Here, fixed displacement compressor compare the set point and the cabin temperature. If the cabin temperature exceeds the set point, engage the compressor clutch. If the cabin temperature falls below the set point, disengage the culture. Add the time delay to prevent the frequent cycling. Next, let's see about the variable displacement compressor. Continuously monitoring the cabin temperature and calculate the error. Use a proportional integral derivative controller to determine the required compressor displacement. Adjust the displacement control valve to modulate refrigerant flow and meet cooling demand. Implementation steps. Hardware prototyping. Select the suitable sensors and actuators. Design and fabricate the PCB for the controller. Software development. Develop the control algorithms for temperature regulations. System integration. Calibrate the sensors and actuators and test the system under various conditions. Safety features, high pressure cutoff to protect the system and overheat protection for the compressor. Let us see the advantage of the semi-automatic control. It provides the balance between the user intervention and automated performance optimization, enhances the energy efficient and comfort compared to fully manual system. Next, reduces the wear and tear on components by intelligently managing the operation cycles. Thank you.